Well, I want to thank everyone again for coming and hanging out with me for the next 30, 40 minutes as we talk about some cool stuff around Airflow. But first, I don't know if you missed who I am. My name's Hendryx-Parker. I am CTO and co-founder of 6 Feet Up. We are a Python and cloud consulting company, and we help impactful leaders accelerate their digital transformations, and we have just really cool customers. One of our customers, this presentation is based off of a couple-year journey that we have done with one of our customers, and that I'll talk about. And actually, last year there was a presentation at Python Web Conference that kind of gave a bigger architectural. Am I not working on the sound here? I'm not muted. Should be working. Saw someone ask for sound. Also, if you have questions during this talk, feel free to throw that into the Slack channel, because I am watching the Slack and happy to answer questions as we go. Perfect. Thanks, Greg, for letting me know that we are good to go. So as I was mentioning before, the talk is about a specific client we worked with last year, or over the last couple of years. Is actually one of our impactful clients, because they're doing some really interesting things in the healthcare space around big data. And when I say big data, these folks kind of are on the top end of the big data thing. And that's why they became impactful, is because we are talking about, healthcare data, COVID data, research data, potentially genomic data, and being able to handle that kind of data in a massive fashion, but keeping it inside of their organization and not having to ship it out outside their kind of data center or on-premises or cloud footprint, to have those kinds of things actually processed. That talk that I gave last year with the technical director from that group is on YouTube right now, and that'll give you kind of the big picture of where this all came from, kind of the architecture. I talk about that in that specific talk. This talk is going to be a lot more narrowly focused on some of the scale issues that have resulted in deploying this into production and actually scaling this up into tens of thousands of actual DAGs. If you're using Airflow, you'll know what a DAG is, and I'll go over that real quick to kind of talk about what a DAG is, so you can get to understand. So the reasons you should really be listening to this talk, because there are some people out there who have either had experiences with Airflow and maybe they weren't positive. Maybe you think Airflow is the wrong tool for you. Maybe you think Airflow can't scale to your needs. I'm here to tell you Airflow can do a lot of things, and actually I believe it can actually scale to handle most of the things that you probably would care about. The customer we had dealt with probably is, like I mentioned, on the bigger end of the scale of big data. And if they can do it, I think your problems can also probably be solved with Airflow. So let's dive in on Airflow. But before we do, this is one of the things I always love to do in my talks. And if you've never seen me speak before, you'll know that or if you have seen me speak, you'll know I do this, is I love to set an intention. And I always love to have my intentions come from the Zen of Python. If you've never read the Zen of Python, it's an Easter egg built into Python. I can't remember what version it came out in. Not important, but if you just do Python -m this, or just go to import this from a Python REPL, you'll get the Zen of Python. And the first 4 here are going to be really important for this specific talk. Is that beautiful is better than ugly, explicit is better than implicit, simple is better than complex, and complex is better than complicated. And those are you'll kind of hear me talk through this talk about keeping things simple, making sure that it can be performed and that it is not complicated. We want to keep things understandable. Now, if you've not used Airflow at all, you may want to check out a more intro talk, but I will go over the fact that these are some of the main components of Airflow. But Airflow in general is a giant orchestration and scheduling tool. You can think about it as like cron on steroids, or if you've used Celery and Celery Beat, it's basically a whole bunch of more tooling wrapped around like Celery and Celery Beat, or different kinds of executors that can do things on a schedule or can react to things in an environment. So a DAG is a directed acyclic graph. The DAGs are made up of tasks. Basically, they're series of tasks which are made up of operators and sensors. Those operators can do specific kinds of operations for you, like a bash operator, what I'll show off in the demo, Python operators, or there could be more complicated operators in there. Sensors are just things that react to things happening in the environment. So you can have more event-driven as opposed to strictly a batch processing type environment. Connections and hooks are going to be your literally connections to the outside world, how you talk to third-party or external systems or APIs. So if you need to, for example, in the case of this project, talk to Azure Data Factory and then talk to Databricks and be able to talk to Microsoft Synapse, there are going to be built-in hooks that come packaged with Airflow. There are some providers out there who build other hooks and connectors for their various tooling. For example, if you're using the managed Airflow service through Astronomer, they're going to have some additional hooks and connections and actually more operators and things that are kind of baked into their Airflow version of the image. But they're also the ones who maintain the open source Airflow project. A lot of the things that start out in the Astronomer image probably roll down into the Airflow open source project at some point. And then there's the scheduler, which is ultimately the one, the piece deciding what happens when and where inside of Airflow. If we looked at this on a diagram, we can basically see here on the right side of this diagram, we've got the user interface, which if you're familiar with Airflow, actually I'll show you right here. We're going to do a lot of demonstrations here. So we're going to quickly move back and forth between. This is the user interface to Airflow. These are all of your various DAGs. Those DAGs then are made up of those various operators, and that's the user interface part of this. There's multiple containers typically running in your Airflow instance. So you'll have the web server container, the scheduler container, and then the workers, depending on what execution model you have selected. The executor you see there in the scheduler basically calls out into those workers, so you can distribute the work across, lots of cellular workers, or if you're in a Kubernetes environment, you can use a Kubernetes executor to basically distribute that load and scale up and handle all kinds of different types of tasks. There is a DAG directory that we will put your definitions for your various tasks into. That scheduler is constantly watching that directory, scanning it over and over again, which will be key to this talk. And one of the reasons I'm actually even delivering this talk at all. And then the scheduler basically generates all that metadata, puts it in the database, and that's what you see when you're viewing the UI on the web server, is all that coming from the DAG directory itself. So the problem, the reason we're here, why we're all going to talk about this. For that specific project, we thought we would be clever, and not clever in a bad way. You can be too clever and it makes things hard to understand. Remember, the simple is better than complex, and complex is better than complicated. But being able to have, in our case, we had a very simple DAG structure for this very large data pipeline. Mostly it's ingest data, get it to a spot, transform it, and then get it to another spot. Not a superly technical or complicated DAG, and every data source that this customer would want to load into their data warehouse is going to have a DAG inside of Airflow that controls the execution and the scheduling and the SLAs and all the things that kind of happen inside of Airflow itself. So if all these things look very similar, it would make sense that we could build a DAG factory to generate all of our DAGs dynamically for us and not have to have duplicated code, like copy paste code across the whole thing. If you want to try and keep, if you've ever heard of the acronym DRY, do not repeat yourself, we want to keep it as dry as possible so that it's easier to maintain, so it's less surface area for bugs. There's all the kind of benefits you get from having a simpler, smaller, more beautiful code base. But that, as I'll show you here, may have some trouble. And the issue is that Airflow can slow down quite a bit with lots of DAGs, but it doesn't have to be that way. There are some workarounds here that I'll talk about, and the rest of the talk is going to be mostly diving into some of the sample code. Speaking of sample code, what I'm going to do is I'm going to paste into the Slack channel a link to this code. So if you wanted to actually try it on your own, it is totally possible. I'm going to paste a link to the code. It'll look like I'm time traveling because you all are seeing this 30 seconds before I talk about it. But here's the code. So that is the talk, the slides and the code. And so what you'll see on my screen, you'll be able to go to that GitHub repository, clone that out, and actually see it for yourself too. So that is actually this code checked out right here on my file system. So I mentioned, and I think I even showed the fact we've got, in this case, there's 101 actually there's 101 DAGs that are in this specific Airflow instance. And these DAGs are currently being dynamically generated by a single file in the DAGs folder. So if you looked at the file structure over here, this layout is one of the ways you can deploy Airflow. In this case, I'm using Docker Compose, and this came from the Airflow documentation. So I just copy and pasted their stock Docker Compose. I changed a couple settings inside of here to allow me to see configurations and things like that. But basically, this spins up a Postgres, a Redis, an Airflow web server, the scheduler, and the worker. So you see here all of the various pieces I showed you on that architecture diagram. That's all being launched here locally on my one system. And you'll notice that this mounts up certain directories from this source code into the various containers. So on launch, I get my configs, which will come important later, DAGs, logs, and plugins. So the DAGs, any DAG you throw into this DAGs folder will be picked up by the scheduler and then written into the metadata and shown in the UI and available to start doing tasks on the work. So you can see here, I'm kind of showing you worst case factory right now, but it's currently succeeding. Like the worst case factory is actually working, because otherwise you wouldn't see all these DAGs that are in here. Now, I want to show off a little bit of this because it is pretty clever. And I think it's clever and again, in a good way, that if you've got thousands and thousands of database tables that you need to move from one place to another place, you need to have a managed way to do this. And you need to have a way that data engineers can easily onboard and wrap their heads around being able to do this without having to write a bunch of Python code necessarily, because it's pretty much the same task. Get data from one database, transform it and over into another database. They're not doing a lot of overly complicated transforms on that data. So what we did was actually configure the data pipeline using some JSON configuration files, and we basically have one configuration file per table that you may want to load into a database. That is what's actually happening here. So we're loading these configuration files right here in so that we can now use them to generate DAGs in our system. Now, this repository includes some sample code for you for building those kinds of configs. You'll see there's a quick little like build configs Python script. What that does is populates this configs directory, and we broke it up, kind of hashed it by alphabetical letter just to keep it simple. But these configs are pretty simple. It's a simple JSON file with keys and values. They're going to have the names of the DAGs, maybe a source bucket for data, a destination bucket for data. So you could quickly see how this could possibly work, like where you're picking up certain kinds of files, and maybe you're dropping them in some place, and then maybe the stakeholder or system of record person would get notified if there was some kind of a failure, and you can then configure your DAGs to take in these specific data points and use them as part of the configuration for running this factory. So we load all the DAGs in. So now take for every config file that's in that config root, we're going to loop, and you notice this is inside the DAGs folder. So Airflow by default is going to look at any Python module inside of that folder and dynamically keep importing those files over and over again so that it can build up and generate the new DAGs for you. So if I made a change to this file, Airflow would pick it up right away. Now that's great for development, probably not super great for production, and I'll talk about that at the end, kind of more the next steps for this. But all we're doing here is using a context manager to build our DAG objects, our DAG instances. So with that, we pull in the DAG IDs for each one of the configuration files as we loop, and we start now building a DAG. Now, if you're not familiar with building a DAG, it's just Python code, and there's some overloaded operators that Airflow gives you that make this pretty easy to do. Our sample code is just going to do some bash commands against my own system, so calling the date a couple times. So there's a start, precondition, and an end. Now, we've got two kinds of loads typically for this, like full loads and incremental loads, where you're getting a full database dump and moving that across, or maybe you're just getting some partial incremental since the last time either the full or last incremental ran. So this handles both types of loads. And so you can see here, this is the special overloaded operator. This basically, if you kind of picture this as a graph, which if you go over into here, we can view it and see what it looks like as a graph. You'll see here start, precondition. some number of steps and then end cleanup. And then we basically coded this up to do those first couple steps, and the next steps each take incrementally longer and longer time, just so I could simulate some activity happening so they don't all just like complete at once. Plus you can see some of the issues as we start scaling this up. I'm only showing you 100 DAGs right now, but I've proven this out to about 10,000 DAGs. And now this is working at the moment using the worst case scenario, which is this dynamic DAG factory, which generates DAGs, 1 DAG per config file that is in here, which is about, like I said, 101 DAGs between all these configuration files that are over here. Right now, that is taking, if we look at our log stats from the container processing these DAG files, about 22 and a little change seconds to run. And that's for, again, only 100 DAGs that we're processing. I'm going to show you a configuration here. We go over into the admin, go into configurations, and we look at the DAG bag import time. This is going to be important. I'll make this bigger so you can see it. The DAG bag import timeout defaults to 30 seconds. So as soon as we start going over 30 seconds, which I will trigger that to happen right now, we should be able to regenerate these configurations. Let me change the build configs. So instead of 550 of these configurations that is going to go full and incremental, we'll change this up to 500. So we're basically doing a times 10. And I'm going to rebuild that config. So off to the side here, I'm basically rerunning the make file to rebuild the worst case scenario. That'll take a hot second for it to reconfigure, and then I'll just go back in here to the UI. It'll take a minute for, so now instead of generating 101, we should be generating 10 times that. So we should be getting about 1,000 DAG files generated inside of Airflow. And it takes a minute because obviously it has to build these things up, but it will attempt to, almost there. It will give a good best effort here. But what I'm telling you, I'm kind of alluding to what's going to happen here, is that these are going to start taking longer than 30 seconds to actually complete, which obviously is problematic if you're hitting that timeout. Here we go. Now it's loaded the fact that there is metadata about the DAGs, but these DAGs are not here yet. You'll see this is missing from the DAG bag. What Airflow has done is noted the fact that there's going to be DAGs there, and now is going to go through and try and actually generate all those DAGs. And so the DAG processing statistics, you see right here, we're running over 30 seconds at this point. It's probably going to start failing on us. Yeah, here we go, DAG import errors. And so this is what you'll typically see as this error starts to encroach into your space. So as I've scaled up from 101 DAGs, trying to get to the 1,000 mark on these DAGs, the DAG factory is failing on us. It's not going to be able to hit that 30 seconds. Now you may ask yourself, well, I'll just go change that number up. This leads to other cascading unintended consequences that I would not recommend going down. But basically, you're going to have to scale up your hardware, scale up your number of cellular workers, scale up a whole bunch of other things that add a lot of additional complexity into your deployment. And obviously, we're trying to eliminate the complexity from our deployment. We want to make things simpler for ourselves so that we have less to think about, less to hold in our head, less to manage and kind of maintain. But yeah, the 50 was, the 500 was almost perfect because it went up to just right above the 30-second line. But you can see how quickly we run out of our timeout for doing this. Now you may say, well, what is the solution to this problem? And really this problem is incurred by a couple things. The fact that our worst case DAG factory here is actually introducing a 0.1 second sleep. That's actually important. Keeping your DAGs themselves as quick to import as possible is actually really important. So import time, Python grabs this file, reads the Python code that's in it, executes it, and tries to import those modules into the running interpreter. When it does, it actually executes every one of these lines that's in here, And this little sleep, which you could think of as like an external dependency, maybe an API call, or maybe you're using requests, or you're calling some kind of API service inside your cloud, or some metadata service, anything like that. Or it could even be, and this is a problem we ran into, at some point we were using the JSON 5 library, which is great for having that extended JSON spec available to us. But the Python library, even in its own documentation, said there may be 1000x slowdown here, which on a few files, even tens or hundreds of files, is not a big deal. But when you get into thousands or tens of thousands of files, all these things start to compound, and they will lead you to going over this 30-second timeout for this DAG factory. So while we had a benefit of a single file to manage all of our DAG and task operations in, we have a problem is that as this data set or sets of data grow, we're going to run into these timeouts and these scale issues, and the whole system is going to come to basically a screeching halt, like I just demonstrated here. So that's an important aspect to keep in mind here is anything you can do to remove delay, and so we're just simulating it here with the sleep, is going to be important. Even printing and log statements, those kinds of things, need to keep those fairly quiet, because anytime you hit I/O, writing something to a disk someplace, you're going to have incur time. I mean, just writing files takes time. Even those microseconds can all start to add up and compound as this scales out. Okay, so the answer here, let's go back, and we were going to run make, let's see here. So actually, if you run the make command, it'll give you some targets. There's one called better case. So this better case scenario is going to, instead of putting one DAG factory file inside of our DAGs folder, we're changing the model, and we're going to actually copy our, I'll show you the example code here, our DAG Python file multiple times, one per instance of the DAG that we want. So you'll see here this copying the gen DAG from file name to all of our DAGs. So the DAGs folder over here will change now and look a lot more like our configs folder. So the configs folder was hashed by an alphabet. Now our DAGs folder is also hashed by that alphabet. I've kept the number of generations to the 500. So we should be generating about 1,000 DAG files now. And you'll see them all. There's the first, the A's that are in here. Now, each of those files is just a copy of this file here, which is at the very root of our directory here, the gen DAG from file name. So this copied in, unchanged, copied into the DAGs folder and only changed by the file name. We're still loading our configuration files like we did before. So our configuration file is going to basically, instead of looping over every configuration file that's in there, it's going to look for a specific configuration file and write out a copy of this file into the DAGs folder and use the configuration, pull that configuration over. Actually, it reads the configuration still dynamically. So we're still reading the config from the config file directory, but the DAG itself is basically getting its configuration based on, you'll see it right here, load config for DAG file. And you'll see that we're using the file variable right here. That just says the name of my file, go find me the config that matches that file name. So if we look underneath here, you'll see Adams group full, and this is a duplicate, exactly what I was just showing you. It is nothing different from this gen DAG from file name, but it's going to look in configs for Adams group full. And so it knows to, based on its file name, nothing else, nothing in the code, just the name of the file, it knows to go find its file name here for full and incremental and load those up as DAGs inside of Airflow. So let's see, these should already be loaded over here. And since we've started it all from scratch again, it'll log us out. Okay, looks similar. You can see here 979 DAGs loaded. Reason it's a little less than 1,000 is because there's some name collisions sometimes with the Faker library. So we're using the Faker library to generate bogus company names. But you'll see that it's all loaded. The DAG bags are here, and within seconds we've loaded all this, no problem. Like actually, if you look over here on the timings, you can see that that 1/10 of a second is now being distributed across each file individually. We didn't have to change any timeouts. We now went from breaking the 30-second timeout barrier to basically being underneath it easily for every single file that's loaded. So every specific DAG file is now underneath, well underneath the 30-second timeout and loaded no problem. So this is all the Airflow stuff loading in the background. And we can enable some of these and start running some of these DAGs. We'll just trigger some of these guys to run. And here we are running with 1,000 DAGs. If I go into the full load, we can look at the graph and you can see that, yeah, it's actually running successfully and cleaning up right now. So we solved this issue without changing actually our DAG code at all. The DAG code underlying all this is exactly the same. If we go into the gen DAGs from file name, we're now just not looping. So we removed those two loops, the loop that was looping over every config and the loop that was looping over every full or incremental, and replaced it with individual files with a simple, the most simple DAG case you can put into it possible. And it's the exact same steps. Which is nice because the metadata server inside of Airflow is still aware of those DAG names and still tracking them. So you can actually keep track over your history. You still get the old runs if like you had been running with the DAG factory before, and now you want to switch over to this new technique of like writing out individual DAG files. Not a problem. It actually still keeps track of the metadata for each of those runs for you just fine. And this still includes, I think this one does not include the 2 seconds. We could still simulate if you had a sleep time in there. This would still start airing out as you started getting into like higher and higher load times, because loading the DAG bag and then actually having all the DAGs into the UI are kind of two separate operations. And it's important to remember Airflow is continually importing these things. Once it gets done importing all these DAGs, it just is a constant loop, like an event loop that is reading them all again. So reading them all again, reading them all again, reading them all again, which, if you remember what I mentioned, we should avoid doing things like API calls, over and over, or in our DAGs at all. If you just had one API call in here, it's going to now get called 1,000 times every 30, 35 seconds. So you're basically going to denial of service whatever API, or you're going to end up in some kind of a giant bill. For example, in our case, we were using Azure App Config inside of these DAGs to pull in some dynamic information about the infrastructure. The infrastructure was built all with a CI pipeline. These DAGs themselves also were built and configured with a CI pipeline. So we needed to dynamically be able to pull in information about that infrastructure, so we knew the addresses for connecting to this or that, and the passwords, those kinds of things. Those were being pulled in dynamically every time the scheduler was going through that loop, which again, if you start getting up in 2000s, you can see now we're basically going to blow our budget on Azure App Config API calls, and it increases substantially the time, especially if you start getting throttled, that it takes for each of these DAGs to load. So a big issue there solved by doing this. Now, if we go ahead and crank this thing up, let's go ahead and I'll cancel that, pull it back down, and we'll go ahead and modify the code. So if you wanted to play with this a little bit yourself, you can come into the build configs. I'm going to go ahead and just change this number here to like 1,000, so we can build like 2,000 DAGs. See if that works itself. Will work, and we'll make the better case again. So we go. We've got. Change it to, I changed it to 2,000. Yes, no, 1,000. So 1,000 here will build 1,000 full and 1,000 incremental, so 2,000 DAGs. And you'll be able to see now the timing as this reloads and starts to come back up. You can watch as Airflow basically starts importing and bringing in all these DAGs. It'll become pretty clear, that there's some time involved. As I scaled this up to 10,000 earlier, this is just on my local workstation here at my desk, and that took about 17 or 18 minutes to load in 10,000 DAGs. But once they were loaded, they could start doing their operations. I think it was mostly it's writing the metadata into the database, and once those things are loaded, that scan still goes fast, like 10,000 times a tenth of a second is where you're seeing them rescanning the DAGs themselves, but there's still no errors. The system will still come up and allow you to actually run your tasks. So it is true, you can scale Airflow. Hold on, if I can type my password and talk at the same time. Type the password and talk at the same time. Yeah, it's moving a little slower, but it should come up here 1 second. Yeah, see, it's still reading in just the fact that those files are there, and now it's starting to process them actually read the DAG definitions into Airflow itself. So we'll take a hot second for us to get to 2000, but it still should lead to a very stable and usable system. And again, this is running locally on my laptop using Docker Compose with Docker Desktop I'm on an M1 Mac right now. Everything's running natively on M1, but obviously it's still running in a virtual machine behind the scenes. So this obviously will be a lot more efficient if it was running in production on Linux VMs with Linux containers, since you don't have the extra virtualization layer and all that along inside there. Now, while that's loading, another thing you want to do to basically work on optimizing this whole process is going to be, I mentioned reducing any kind of noise, debug logs, print statements. You want to basically remove all that extra noise because it creates overhead as you start to scale up. But you're also going to want to, basically start fully packaging this into its own Python package so that you can ship all the data you needed without having to do lookups. So in our case, we've got the lookups for the config files. Those could be technically written out into the DAG files themselves dynamically. So you would never modify a DAG file directly that's in this folder. You would still modify your one root DAG file, but the configs would then allow you to write kind of hard code or output hard-coded DAG files for you. So you generate or template them. Now, I say the word template. DAG files themselves support templating the operators with Jinja templates. I would recommend against that. I would actually template it the other way. Like, for example, you would use Jinja templates to output the DAG files themselves, the full DAG files, so they can easily be debugged. If the template is part of your operator, if we go into here and we look at the operators down at the bottom, this command can get interpreted as a Jinja string. But if your code and logic is in the Jinja string itself, then it becomes very difficult to debug that specific command, as opposed to being able to drop into the interpreter here. And if you've just used Python in your DAG file itself, doing things like debugging becomes a lot simpler. Let's see if Airflow's come up. Yeah, it is. So you'll see right now we're at 1,000. And it's still going up. Others at 2,000 now. So you kind of saw before it was like 1,200 and 1,000. So it was still, the UI was available. The DAGs were still being imported into the metadata server on the Postgres side. But you'll notice that even though I've been changing these around and adding in 1,000 more DAGs, they are available. The old ones that were still running from before, the history is still here. And I can now enable new ones to be run. I think these should be, yep, so it's already imported them, DAG bags there, where before, as the dynamic one was the DAG factory dynamic one, where there's a single file, it was saying not in the DAG bag, and then eventually it failed out because it was taking longer than 30 seconds to run. That is no longer a problem. So you can basically set these up to run. So again, last steps here is going to be around some of these optimizations. Anything you can do to speed up the time it takes for Airflow to import your modules is the better. If we look here, there's an optimization in our build DAGs. You'll see it right here. We are importing that module during the build DAG stage. So what you're not seeing, and maybe I can just go over into the file system here and look. If I go into the DAGs folder, you'll see the under PyCache. When Airflow reads in your DAG files, they'll get cached in that PyCache folder as PYC files. You can basically pre-generate those, and that's exactly what this code is doing right here. It's basically pre-generating that PyCache folder populated with all the byte-compiled Python code, which is just another little optimization to speed things up. And as you get into, again, thousands of these things being read in, any little optimization you can do to speed up those first reads is going to be really important to getting to a working UI fast and eliminating some of these timeout errors and issues. Let me make sure I've not missed anything else I wanted to cover here at the end. Yeah, because the import time is really, really important here. And again, the last step is that building this into a repeatable, deployable, deliverable container. Right now, I've not modified the Airflow container that came from Docker Hub for Airflow itself. This is basically running stock Airflow container and just bind mounting in the DAGs directory, the plugins directory, the logs directory, so that I can work with it locally on my local machine. But when it comes to operating in a more productionized environment, you're going to want to build your own custom version of the Airflow image that has baked in these, generated DAGs that have all the data needed for operating against a certain version of your environment. So as you run your CI pipeline to build this, you may also be running in parallel a CI environment that is building your infrastructure. And we did that. We used Terraform with Jinja to build out things like Azure Data Factory pipelines, so that they can match up with the new source files that are being put in by the data engineer. So if a new source is being onboarded into the system, the Terraform will build out the infrastructure, the corresponding infrastructure that goes with these DAGs at the same time, so that you always have the DAGs matching up with the infrastructure matching up with the source files you're bringing in. And that is pretty much the demo of the problem, the root cause of the problem, which we saw was time, and the solutions. So I recommend folks do start with DAG factories. If your data sets are small and you don't have these thousands of DAGs kind of problem, that dynamic DAG factory is nice because it basically makes your code a lot simpler. As you scale up, you can do this static generation where we generate those DAG files and put them into a pre-compiled, pre-built container that will release into our Kubernetes or whatever your container environment of choice may be. And that basically allows you to pre-compute configurations, pre-compute the data needed during the build, because that'll make this whole thing a lot faster. And then make sure you're always optimized. We haven't even gotten into the tasks themselves running inside of Airflow. This is literally just how do we get lots and lots of DAGs running in parallel. Make sure you optimize your runs for your tasks to run in parallel, and you'll have a great life with Airflow. The Airflow docs are actually really, really good. I highly recommend them. Some more background on what we did here for this specific project is in the Too Big for DAG Factories post. I'll put a link to it into the Slack channel as well. And you can find me on Mastodon and on Twitter, on the Twitter sphere. And I'm always available to answer questions. I love talking to people, especially when I get to geek out on cool Python stuff. So I want to thank you all for being here and being part of Python Web Conference. If there's any questions, I will definitely be over in the face-to-face room. I didn't see anything coming in through the Slack channel, or I would have answered them live for you.